Hello everyone, I'm Dr. Rajesh and today we will study properties of a forward operator, that is delta operator. So this is forward difference operator. Forward difference operator, also known as delta operator. Fine. First property is that delta C is equal to 0 where C is some constant. Done. So delta C can be written as C is a constant function, so it will have at x plus h, it will also have the value C, and at x also have a value C, so this will cancel out. This is 0. So first thing is proved that delta C where C is some constant is equal to 0. This is a first property. Now we will study the second property. It states that delta and C commute with each other. This property is known as commutative property. Done. So now apply it upon f of x. Done. So this is equal to delta C f of x. This is further equal to, now this forward difference operator will apply upon this one, so this will be C f of x plus h minus C is a constant quantity, so it will not change. This will be f of x. Otherwise it is something like CF x. Fine. So C will not change, so it will remain the same in both. So it will be f x plus h f of x. So this will be, C will be outside, f of x plus h minus f of x. So by definition this is nothing but delta fx. So this is further equal to C delta f of x. This implies that delta C is equal to C delta. So this was required to prove. This property is known as commutative property. Now we will study the third property, and third property states that delta f plus g is equal to delta f plus delta g, and this property is known as distributive property. Because this delta is distributive inside over f and g, hence the property is distributive property. Now we will prove this one, and for the same let us take the delta f plus g since these are already functions, so they need the input argument x. This will be delta f of x plus g of x. Done. So this will be, now apply the definition of delta. It states that this will be f of x plus h plus g x plus h minus f of x plus g of x. Now collect this thing with this one, this thing, and with this one, we get f of x plus h minus f of x plus g x plus h minus g of x. Now by definition, this is delta f of x and this is delta g of x. Now this x is the input value, because functions are already present, so you need only the input value x, and this is holding for every x, this is also holding for every x, so this thing is equal to this thing. This implies that delta f plus g is equal to delta f plus delta g. So this thing was required to prove. Now we will study the next property, and that property states that, so I am going to write it over here, that delta af plus bg is equal to a delta f plus b delta g. This is property number 4. Now this is delta af plus bg. Now see the proof. From the property number 3, we know that this delta is distributive over addition, so it will become delta af plus delta bg. Find by property 3. Done. So once again, by property number, the property, there is one more property, that this, whenever we have the constant a and b are here constant, okay, so this will come out of this. So as of now we don't have the proof, so I am going to prove this thing first. Delta cf, so since f is already here, so you need the argument. Let us take delta cf. Cf will be more appropriate, it will be more appropriate, where c is constant quantity. Since function is over here, so you need the input is x, so this will be delta c f of x. On the same lines, now on the same lines you will show that this is c delta, so I am going to write it directly, c delta f of x. Now this is further equal to c delta f, and here is x. So for all x, this will be delta CF is equal to C delta F, where C is some constant. Okay, now use this result that this C will come out over here. Using this result in equation number 1, we get, using in 1 we get, it will be delta AF plus BG. This will become, A will come out because A is a constant quantity. A delta F, B will come out, this will be delta G, and you have to mention where A and B are constants here. So this is the property number 4th, this is 3rd, and this is 2, and this one is property number 1. Now we will move towards the property number 5. This is property number 5. So we will try to establish the proof of this property number 5. So this can be written as delta f of x dot g of x. Now use the value of forward operator. It states that f of x plus h, g of x plus h minus f of x, g of x. So this will be now further f of x plus h, g of x plus h. Now since here x plus h is common, so I am going to take this term as x plus h, and here is gx, so that whenever we will take common, so this will form the forward operator. Since I have subtracted, so I am going to add the same thing, because we know that 1 minus 1 is equal to 0. F of x, g of x. So this thing is equal to f of x plus h will be common, g of x plus h minus g of x. From here you can take gx common. So this will be f of x minus h, x plus h minus f of x. This will be further equal to f of x plus h, this will be delta g by definition, plus g of x, this is delta f of x. This was required to prove. Okay, so now I am going to write the next property, that the proof I am going to leave up to you only. This thing, okay, and you have to prove that this is equal to gx delta f of x minus fx delta g of x divided by g of x plus h, and it will be g of x. So I am leaving it as exercise, do it yourself. Okay, so hint I could drop for you that you will use delta f of x by g of x. You will use it by definition of delta. This will be f of x plus h. This will be g of x plus h minus f of x divided by g of x. Done. And now further you will do it yourself. So that's all I have from this lecture. In this lecture we have studied 6 important properties of forward difference operator, and these properties are important from the examination point of view. So that is all I have from this lecture. And if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye. Take care. Bye bye.